In this video, I'm introducing a form of integration called U-Substitution. So when we learned how to find derivatives, we learned the chain rule. And the chain rule was what we used for finding the derivative of a function inside of another function. So an example of that can be found here in this first example. We have an inside function, which we generally refer to as u. So in this case, u would be 4x squared plus 5. And we would have n, which would be 3, which is the power. So u is the inside function, what's inside the parentheses, and n is the power that it's being raised to. And to do this problem, we would also have to find the derivative of u with respect to x, which would be 8x. Now to actually find the derivative, f prime of x, we would bring the 3 down out in front, times our u, but instead of writing u, most of the time we just got used to just writing in the actual function for u. And then we would decrease n by 1, so that would be 2. And then we would multiply that by the derivative of u, which is 8x. And then we would kind of clean it up a little bit. And we would have 24x times 4x squared plus 5 squared. Now suppose we wanted to find the antiderivative of that. In other words, we wanted to find the antiderivative of 24x times 4x squared plus 5 dx, squared dx. So remember that this notation tells us we want to find the antiderivative of the function that's in between the integral sign and the dx. And so just like we did up here, we want to identify what u is. Okay, u down here is exactly the same as u here. In this case, n is going to be different. N now is the exponent, but now n is equal to 2. And then all of this stuff, I just call it everything else, the 24x dx. You'll see what we're going to be doing with that when we actually get into the process. First, let's just do a couple more problems where we have to identify u and n. So we want to find the antiderivative of this function. The first thing that's necessary to do is identify that we have a composite function, and the inside function u would be 3x squared plus 4, and n is going to be equal to the exponent 2. Here we have another composite function, and we want to rewrite this perhaps as 2x squared times x cubed plus 3 to the 1/2 power dx. So you can see we have a composite function, a function inside of another function. My inside function, u, is x cubed plus 3, and n is the exponent, which is 1/2. And then we have all this other stuff, which we'll play around with here in a moment. Okay, so that's the first step. When you see that you have to find the antiderivative of something, you realize it's a composite function, identify what u and n are, and then you can proceed with U-substitution. So let's do a couple of examples of the whole process. So here's one we actually want to find the antiderivative of. And so, as I said, the first step is to identify what u is. U is the inside function inside the parentheses. But what we want to do now is we want to find the derivative of this, du dx. All right, so that's just going to be 16x. And then what we want to do is we want to solve this for dx. So we want to solve for dx. And to do that, multiply both sides by dx. They cancel out here. And so we're going to have du is equal to 16x dx, and then divide both sides by 16x. And we'll end up with dx being equal to, because these will cancel out here, being equal to du over 16x. So this is important. We're going to need this in our substitution. We're going to need this in our substitution. And of course, n in this particular case is 10. So we're going to need this, we're going to need this, and we're going to need this to do U-substitution. All right, so let's do it. Well, first of all, we have an integral sign, and then we have that other stuff. I keep calling it the other stuff. Well, we're just going to write the 6x that's part of that other stuff. Write it down. And then we have our u raised to the n power. So I'm going to take out the 8x squared minus 24 and put in u. And that's raised to the 10th power. And now we have dx. We're going to get rid of dx, and we're going to put in what dx is equal to. Well, dx is equal to du over 16x. So I'm going to put in du over 16x. Now our objective here is to get rid of all of the x's here. Get rid of the x's. Get rid of the x's. So I need to get rid of this and this. Well, guess what? They cancel out. Yeah, this is in the numerator. That's in the denominator. So boom, they go away. So what I'm left with is integral. And let's put the 6 over 16 out in front of u to the 10th times du. Now, the 6 from here came from this number, and then the 16 came from this 16 down here in the denominator, okay? Because that's underneath the du. Well, now all we need to do to integrate this is use the power rule. Very simple. Now that we've done our U-substitution, we can integrate using the power rule. This reduces to 3/8. And then u to the 10th using the power rule would be u to the 11th divided by 11, which is going to be 3 over 88, 8 times 11, times u to the 11th plus c. And now let's write that as 3 over 88. Now what was u? U was 8x squared minus 24. So let's substitute back in what u is equal to, 8x squared minus 24 to the 11th power plus c. And there is my answer. We have now found the antiderivative using U-substitution. All right, let's try another one here. So in this case, my u will be what's underneath the radical, 6x to the 8th plus 7. The derivative of that is 6 times 8 is 48 x to the 7th. And then solving it for dx, we will end up with du over 48 x to the 7th. So again, we want to keep this handy, and we want to keep this handy. And of course, we know that n is 1/2. So now let's do the substitution. We have the integral of 7x to the 7th, that's that other stuff. And then we have u to the 1/2 power. Remember, so we're taking out this and we're putting in the fact that it's equal to u. And then we're raising it to the n power. And now we're going to take out the dx and we're going to put in what dx is equal to, which is du over 48 x to the 7th. So in the previous problem, I said our objective is to get rid of the x's. And notice that we have an x to the 7th and an x to the 7th and they simply cancel out. So what we're left with, again, I'm going to put the 7 in front of the integral sign. We have u to the 1/2 du. And now we can apply the power rule. We have 7 u to the 3/2 divided by 3/2 or times 2/3, which would be 14/3 u to the 3/2, which becomes 14/3. What was u again? U is 6x to the 8 plus 7 raised to the 3/2 power plus c. Don't forget the plus c at the very end. And that would be your answer. Now, for either of these two problems we did, just for the fun of it, take the derivative. Find the derivative of this, and you will end up with what you started with. Okay, let's do one more problem for this video. Here we have a composite function. We have a function inside parentheses raised to a power. So u is 6x plus 9. The derivative of that, du dx, is just plain old 6. Or dx is du divided by 6. N is 15. So this becomes the integral of 8 u to the 15th. And now we want to take out dx and put in what dx is equal to, which is du over 6. And nothing to cancel out. There are no x's, so we're good. So let's bring the 8/6, which is 4/3, out in front. And we have u to the 15th du. Now we can apply the power rule. So that would give us 4/3 u to the 16 divided by 16, which now, let's see, this 4 cancels with that 4 times. So we have 1 over 12. So 1/12 u to the 16, which becomes 1 over 12. Substituting back in, 6x plus 9 to the 16th power plus c. And there is my final answer. All right, that's it for this video.